Today I want to have a good look at the channel Boolean tool in Fusion. This is probably the most basic and at the same time most advanced and powerful tool in Fusion. It can be a bit intimidating because it allows you to do mathematical operations on images, and I know that can sound a bit scary, but I assure you it doesn't have to be. So I got a few tutorial requests for this tool, that's why I'm making this tutorial, and I want to show you a few completely different but not very difficult examples where I use this tool in very different ways, and I think this will help you get a better grasp on what this tool is and where you can use the kind of logical operations that it allows you to do. So whether you have never used it or whether you're just a little bit unsure about all the opportunities that it gives you, let's have a look. First, let me start by having a look at the controls of this tool. So I have already a few things here in my flow which I will use now for demonstrating, and a good way is always to start with, some simple test images like this, because it's easy to understand what's happening. Let me bring in the channel Boolean tool from here and just connect one image, bring this on the right side of the viewer, so be here, be there. And right now, if I connect one image, nothing happened. If I connect the second image, then you see it just got replaced. So I just got my image replaced, and the reason is there's an operation here which says copy, and any operation that is happening here is happening channel by channel. So by default, we have the 4 channels, red, green, blue, and alpha. And here it just replaces each of those channels from my background image B with the equivalent channels from A. So basically I'm just getting image A. That's the default what this tool does without changing anything. It doesn't sound super helpful, but we come to a few modifications now. So first of all, if I have 2 channels connected, then my operation applies whatever operation I have from the foreground to the background. So for example, if I change this to add, now I'm adding my foreground channels to the background channel. So pixel by pixel, it takes the value. So for example, in the red channel, it takes the red value from A and sums it together with the red channel from image B in this case, right? So, and so on. Same for green, same for alpha. If I have only one image connected, and let me go back to copy or add, doesn't matter, then the foreground channels here it says red foreground, green foreground, blue foreground. These foreground channels here, which are currently not connected, are actually the same as the background channels. So I could switch here to background and it's the same, nothing happens. But now I can, where it gets interesting, I can start changing channels here. So for example, I can take my alpha channel and say, make the alpha channel white. So here I just have some, or even mid-gray white. So now my alpha channel was replaced, and I can look into the alpha channel, it's completely white. Before I did this, let me just disable the tool. I had this alpha channel for this rectangle, right? So I just replaced a channel in this case. And then when I have 2 images together, I can replace even between images. So let me undo this. I can say, for example, do nothing at all on the alpha channel. And let me go back into the color image. Do nothing on the alpha channel. I keep the alpha channel from here, which is now this one here, the black box here, but I am copying my foreground channel. So I'm copying the color pixels everywhere and keep the alpha channel. Now, okay, this looks really not very useful, right? But this is just the way how the logic works. Let's do one useful thing just on the test image. Let's say you want a monochrome image, for example. I have here my only my background image, and again, background and foreground is the same. Let's say I want to see only the red channel. I could pipe the red channel into all channels. So red is red foreground, green, I also put to red foreground, blue, I also put to red foreground, and alpha, I don't need to do anything. And now I have a monochrome image, right? Monochrome red image. So it's not very colorful here, right? But everything that's not red gets black, and there's a red component in the white font. That's why we keep it white. If I change this to blue foreground, I get a monochrome blue image, and now this is just white because, you know, blue gets set to white and there's a 100% blue component inside white, so I just get a white rectangle. I think I have to go away from these test images, but generally speaking, these are the kind of operations you can do. You can shuffle channels around, you can sum channels together, subtract them, multiply, divide, and so on. Some of these you also see in the merge node. So there are many cases where you can use the merge node and the channel Boolean node in a similar place. But the channel Boolean node really allows you to go channel by channel, go into individual channels and take them out or manipulate them. Let's have a look at some examples, and I think this will make things a little bit clearer. In my first example, I want to start very simple and just manipulate a mask channel alone. Here I have, this is from the Blender Tears of Steel movie, just a simple frame for a green screen movie. And up here I have an alpha channel for this. Now, why do I have this separately? There could be multiple reasons. One reason could be I have an elaborate keying process which gives me that alpha channel from the delta keyer, from other masks, even rotoscoping. But during that process, I might have done different manipulations to the image, and later I want to go back to the original image and just apply that alpha channel. Often we separate keying from despill, for example. I have like a lot of discussion on this in my compositing course. Here, just to demonstrate the Boolean tool, I have done something with my original image, and here I have something else to create the mask. So let me add the channel Boolean node here. And what I need to do, connect it to the foreground. And now I can just multiply this channel here with my background, and multiplication with the mask means that wherever the mask is 1 or white, my pixels stay in place. Wherever the mask is black or 0, I get 0, and in between I multiply the value so that semi-transparent areas are also correct. If something is 25% transparent, I multiply with 0.25, internally Fusion multiplies, and this way I'm getting the mask applied. So I go here to multiply, and this image here, the mask image, is in all channels, RGB, alpha. Actually, it's a mask channel, but I just multiply like this, and the output is that my mask got applied. Now, there are other ways to apply a mask. There are these checkboxes, multiply by mask, in lots of different tools, but this is just one very clear and clean way. I just show you, okay, this is only doing a multiplication channel by channel, and this is how it works. Sometimes you might also get a masked channel from externally, like if another artist created a masked channel or another software, and the channel could even be in a different, it doesn't have to be in all channels. Maybe you just get a monochrome image in RGB without alpha channel, and then, you know, you can just use, let's say, the red channel only. If you know the red channel contains the mask, then you just use the red channel, multiply everything, and this way, again, you get your mask applied. So here an example for masking. Now, sometimes you need to invert masks. Again, there are many tools which have a checkbox somewhere, invert mask, but not all tools have that, and sometimes it just makes sense to do it manually. So I can just use a channel Boolean tool, click here on negative. Where is it? Here, negative. And this just, I need to connect again. I need to connect it to the background. So my mask, previously I had this. I do a negative, I get the inverse mask. And now I have, done the opposite. I've removed my character and keyed my background instead of my foreground. Doesn't make sense here, but you know, every now and then you just need to invert just one channel Boolean and you're there. Talking about the negative operation, let me go to a small fun example where I'm using this to invert an effect. And I recently saw this on a trainer seminar, and I thought it was so funny that I just show you. Whether or not it's useful, you can decide. Here I have a simple image of a warehouse, and let's say I have a certain effect which depends on brightness or depends on a certain color. And you might try to invert the effect using the channel Boolean. So that's more difficult to say than actually to do. So let me just add a glow here as an example. So the glow does a kind of blur and intensification of highlights, right? So glow, or there's also the highlight tool, and there are different tools which work on highlights. Let's say I don't want to work on highlights, but I want to work on dark areas with a similar type of effect. So in this case, I could use the channel Boolean just to invert the operation I'm doing. Actually, not invert the operation, but invert the image. So I add a channel Boolean in here, set it to negative, negative, and I don't even want to look at this right now. I just do the same inversion again at the end and put a second channel Boolean at the end and bring this into the image. And again, in between, looking at negative images may not be very, intuitive, but we know that what is bright in a normal image is dark in a negative image, and colors are swapped and so on. So everything is kind of inverted. And now let's see what happened to the glow. So instead of glowing my bright areas before, I have some strange dark glow effect. So not sure if I ever want to use this particular effect, but just as a fun example, I can now glow or intensify and blur the dark areas of an image. Could be useful someday, who knows. By the way, I saw this technique first demonstrated by Eric Westphal, and I'm mentioning this not only because Eric is showing these great examples, but also because I wanted to point out the We Suck Less Fusion forum once here. This is a forum where Eric is a top contributor and where you find many other experienced Fusion artists. Personally, I'm working a lot with video tutorials, but if you are looking for a forum where Fusion artists help each other and, let's say, take a bit more time to discuss topics rather than on Facebook or in the YouTube comments, then this may be a place you may want to check out. So if you are looking for a forum, have a look at this one. Okay, let me continue. This was an example for the negative operation. Let me show you an example with subtraction. And I'm going now to a classical compositing example. And here I want to work with video footage, and video footage has video noise, right? As soon as you zoom in far enough, and let me just zoom into one area of this coffee mug example, in one dark area, I think it should be most visible, then you see some blocky noise here. Now you might also see noise due to YouTube's compression artifacts. Maybe the image for you is not as clear as it is here in front of me, but in a minute you will see I will exaggerate things so that you can actually see what's happening. So definitely whenever you have video, you have noise. And let me do some compositing here. First I add my logo to the mug. That should be fine because I am multiplying the logo over the background, and whatever noise was there in the background still shines through to some degree with the multiplication, so it just gets darker. That should be fine. But what if I do some more severe change here and remove the left side of this image? And I do this with adding a simple paint. So here I have this part. Let's say I don't like it, or I want to place something else later in this image, and I am doing this. So I have added a paint to this video, so I just painted in Photoshop. I just took one frame, painted a little bit, and I know this paint is not very, it's not like high quality paint job, but it's just a simple way to illustrate the point. So just a simple extension here, a set extension if you want to. Now, if I painted something in Photoshop, then it won't have noise, right? The video has noise, the painting here not. So if I zoom in here, I won't see any noise at all. It's just at least no animated noise, right? So now I need to make sure that it's consistent, right? That my video noise and the area that I painted don't fall apart, but behave in pretty much the same way. There are different ways how you can achieve this, and I show you just one way, which is quite typical. I work on a denoised version of the footage instead of the noisy version. There is a noise removal tool in Fusion. It's not very good. You can use a blur to some degree. Blur just averages out pixels, right, which also reduces noise. A bit better, you can use the noise removal from the color page in DaVinci Resolve. Or you can use external plugins. Here I created a denoise clip from the color page of DaVinci Resolve. I rendered it out, brought it back in here. So I have here a denoised version of my image, and I just use that denoised version and do my compositing on this. And you can actually see, if I zoom in here, you see hardly any noise if I play it back, right? There's hardly anything you can see here. Also in the channel, blue channel, tiny, or now I see the fork here, but the steam, there's hardly any noise in the denoise, so it's a pretty good denoise. Now I can use this denoise for my compositing. However, if I am compositing with the denoised version, at the end I want to go back to my original image as much as possible, right? All the areas where I don't do modification, I want to keep my original image. So what I can do is I can just subtract the noise and add it again at the end. Very simple step. I use a channel Boolean, connect my original noisy image, and from my noisy image I subtract my denoised version, subtract, and I don't need to do anything with the alpha channel. It's just, I mean, there's no alpha channel here. I'm just subtracting, and if I subtract, you see just black, but that's because the noise is very low. Let me intensify it now, then you can see the noise. So now I really bring up the gamma in the viewer, and you see this is the noise. And there are a few artifacts which the denoise algorithm captured as well, and I'm not too worried about this. You have to watch out for it, but this is really an exaggeration right now, so I'm not worried right now about those artifacts. Sometimes if you are compositing in those areas, you have to be a little bit careful. And there are other ways to do this as well, like apply noise only in some areas or create synthetic noise and so on. So there's a lot that you can do with noise. But just to demonstrate my simple flow, I'm subtracting it here, adding it again. Again, nothing to do with the alpha channel. So the noise that I subtracted, I add again at the end. And at the end, I end up with let me reset the viewer, I end up with a final composite image which has the original noise even on those areas where I painted. So if I zoom in here, you now see, if YouTube conveys it properly, you now see a bit of blockiness here, a bit of noise, maybe a bit better if I go into the different channels, red, green, blue. Yeah, so it may not be very visible, but it is definitely there. So I have solved my problem of a static photo and have added the video noise. Of course, if you have very noisy image, very dark areas, or even film grain or so, it may be more important than in the example I have shown you here. But this is the general principle. And here I just subtracted something, subtracted the noise, added it again. That's it. So I have done different mathematical operations on images, plus, minus, multiplication, and inversion, negative. So these are the things I've done so far. Now I want to use this to rebuild our everyday merge node. And it shows you how simple compositing operations that we use relate back to even simpler concepts. Now you can look into books or Google it and find out what the mathematical operations behind many tools are, like how a blur works, how a merge node works. But I think sometimes it's just interesting and helpful to understand what is behind those concepts, even in a more visual way. That's why I think, since we are using the merge node all the time, I think it's helpful to once see how it's actually being built. And I only need 3 channel Boolean nodes for this. And this is what I want to do now. Here is my academic image A and B, just simple test images to illustrate the point. And if I just merge them and not changing any settings here, my just simple merge node A over B, exactly how we always do it, right? And this somehow intuitively makes sense. It's somehow, okay, I take this image and I throw it on top. I just add it to this, right? Let's see, is this just like adding, right? Is this just adding A to B? Let's see, I just use a channel Boolean node and set it to add. And I add the B image in the background and I add the A image in the foreground. And let's see, looks almost the same, but actually it's not. Let me just use one viewer with a split comparison and put it in here. Sorry, right side and left side I keep my merge. And you see in the semi-transparent overlapping areas here in this block, the color is actually wrong, what my channel Boolean did. So let's see why this is. So this was just the add. Let me name it this way. So this is A plus B. And what I'm not considering when I just add is that in areas where I have overlap, I am here also adding the alpha channel and the pixels. So I could even get out of range values actually with just adding like this. And when I do like overlapping the way the merge node works, I actually have to modify here my background. I can't just keep my background values and just add something on top. I have to reduce the background values in those areas where the A image comes on top. So I have to not just add things together, but where the A comes on top, I have to remove the B values accordingly. So I have to subtract something. Let me add this as a channel Boolean, and here I do subtract, and I also call this, I just call it minus for simplicity. So I have to subtract something. And what do I have to subtract? I have to subtract the area, again, where the B values and where there's the overlap. So I have to subtract B values from based on the alpha channel of the A values. And this I can do with a multiplication. So let me connect the B channel here, set this to multiply, and multiply not the whole A channel, but only the alpha channel. So I'm only worried about the amount by which this is overlapping, the transparency values. So I use the alpha channel of my A foreground and multiply this with my background, and thereby my background gets reduced by the foreground alpha. So if I look only at this, let me disable this, I am reducing, I'm taking the component of the background which is being replaced with the foreground, that component, rename it to, this is background B multiplied with only the alpha channel from A. I just call it A alpha just to visualize this. And this is the part I have too much in my simple addition, so I am subtracting this part. And now let's see if I did this right. Now I have a different way of adding A and B, and let me again do the split comparison with the merge node on the left and the minus on the right. And you see split comparison proves it. There is no difference at all. So with these three nodes, I just rebuilt my merge node. So basically many of our compositing operations actually relate back to mathematical expressions, and you can find them in books, you can find them online. Here, this merge is so simple that I think everyone should have seen it at least once, even if, of course, I don't do this every day, right? I just do this now once for illustration. But it's really not much more complicated than this. You just have to wrap your mind a little bit about the image logic and how the transparency works, and then you do have, control over this. Let's go back and finish with one nice compositing example again, and this time I'm looking at a 3D example, and I only want to talk about the channel Boolean, so I have prepared something up front. I have prepared a simple 3D model here, and just to make it nicer, let me disable the checker underlay. So here is my 3D text, just a very simple text 3D in Fusion, so I won't go into the details here. If you want, I can do another time. But it does have some highlights here, it does have some reflections, it does have shadows of different kinds. And what I did is I just separated those different image components apart. And this is something that's typical when you work with 3D applications and do 2D compositing afterwards. So if you work with Blender or Maya, or you work with a 3D artist together, it's typical that they render in passes. And let me just show you how this looks like. And here I just simulated it in Fusion just for illustration. But instead of giving you just this final image, you get multiple component images. For example, here I have one image is called diffuse pass, which doesn't have any impact of no highlights, no reflection. There are brighter and darker areas from the light source, but there are no shadows which the geometry itself creates. So this would be called a diffuse pass. You may have specularity, so there are different areas which are shiny, like highlights from metal or highlights from objects that are just, reflecting like mirror-like properties in certain areas. So I have this separated out, and here I have a reflection pass. So here this hue is very dark at the moment, but it's giving a reflection from an environment which has nothing to do with the text itself. It's just the assumption the text is inside an environment, and this gives the reflection. Here I created some shadows. So there are shadows here that the 3D objects throw onto each other or onto itself. So for example, this shadow here is from the 3D object itself. So it's not where the light shines or doesn't shine, but it's where the light casts a shadow from 3D geometry onto other parts of the 3D geometry. And here ambient occlusion, that's a different type of shadow. It just says that less light is falling into tight corners than onto plane surfaces. So these are a few of the typical passes that you may get when you're working with 3D applications or with 3D artists, or that you can even produce in Fusion. Recently I made a spaceship compositing tutorial where I also created different passes. And the advantage of having them is that you can afterwards manipulate them in 2D and can finally adjust them in 2D without having to go back to 3D. So that's the idea of these passes, and the channel Boolean node helps me to just link them together. So I have my diffuse pass, I just do a simple addition. Now I have my specular highlights on top, then I do another addition and I have my reflection added on top. I do a multiplication for the shadows. So I multiply them in so that the dark areas get darker, the bright areas stay the same, and the second type of shadow I'm multiplying again, and the final result is again my full render. But now this time I have just, with simple mathematical operations, I have added different parts of the image together, but now I can control these parts. For example, I can maybe add a brightness and contrast node here for the reflection pass, for example, and I can just, for example, change the gain, and I can bring the reflection all the way up, and I can really fine-tune it without going back, without touching my 3D render. 3D render is the last part that I want to touch, because sometimes you get technical passes, and if you see in your channel Boolean node, you may have already seen, if you scroll down a bit, you see things like Z-buffer, UV textures, normal pass, and so on, vector passes, position pass. So there are different buffers of technical information that can be stored in an image. For example, Z-buffer says how far is the distance of an image, of an object in the scene. Other things give information about the orientation and so on. And these are additional technical passes that can help with certain tools. And if you get them from an external application, you may have to work with these kind of passes, or even in Fusion you can work with these passes. And the channel Boolean node again allows you to manipulate these passes, to load, to shuffle them around. For example, if you load them from externally, you might load them as an RGB image, but then you need to put them into a technical pass like this, and you can again use your RGB here to shuffle them around, or you can go here and even activate additional passes, enable extra channels, and then if you are using these channels inside of Fusion, then you can shuffle passes around or do similar operations what we have done before and add them to those technical channels. So let's say you have a grayscale image for Z depth, you can use the channel Boolean, for example, to assign the red channel to the Z channel, Z buffer, and this way you can take your grayscale image and put it into that technical channel, and then there are tools like the depth blur which can use that technical channel. So that's the idea of these extra channels. All right, whether you are working in 3D or you stick to 2D, I hope you got a bit of a better feeling how simple mathematical operations can help you in compositing. So if you like this, let me know, click the buttons and ask your questions if you have any. Also, if there's anything you want to know in more depth, even from for example, from these examples I showed you, about noise or about 3D. I am covering quite a lot of compositing information also in my compositing training course that you find on my website. I'm currently working on the final chapters, so if you are in for an in-depth training, have a look. Otherwise, yeah, let me know what you want to see on YouTube as well. I will be back with more next week. My name is Bernd. Thanks for watching.